Hello guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 10 JAMB repeated questions on the topic solubility. So guys, ensure to stay till the end of this video. We're going to solve this right here together. So let's start with the first question. It says, okay, here we have a graph here showing solubility, and is a graph of solubility and temperature. So the question here says, from the diagram above, the mass of crystals deposited when 1 dm cube of a saturated solution of sodium chloride is cooled from 80 degrees Celsius to 60 degrees Celsius is. All right, so guys, we're going to zoom into our workspace here and solve these out together. So first of all, the solubility here will be the mass times 1000 over the molar mass times the volume. So guys, since the solubility here can be obtained from this graph, we have, since from the graph they said the saturated solution of sodium chloride is cooled from 80 degrees Celsius to 60 degrees Celsius. So if we are tracing the 80 degrees Celsius, that will be at point 10, and then when we trace the 60 degrees Celsius, that will be at point 8 on the solubility curve here. So that will be solubility here will be 10 minus 8, and that's 2. So since we've gotten solubility, and we can actually calculate for the molar mass of this substance, since it's sodium chloride, sodium is given as 23, and then the chlorine is 35.5. So we can say the molar mass is 23 plus 35.5. So guys, this will give us a total of 58.5. So this is 58.5 grams here. So remember, this is mole per dm cube. So now, since we have the molar mass here, and then we have the volume here as well, and every other thing is set up correct. So the only thing we are looking for now is the mass of the substance, or the mass of the crystals here. So we are going to make this mass the subject of this equation. So we're going to say the mass times 1000 will be the solubility times the molar mass times the volume. So guys, with this we can say the mass here will be the solubility times the molar mass times the volume, and this over 1000 So guys, since we're using this formula here, it means we are going to actually have our volume in cm cube here. So with this, we're going to say our m is equal to the solubility, which is 2 moles per dm cube, times this multiplied by the molar mass, which is 58.5 grams per mole, and then this multiplied by the volume, which is 1000 cm cube. Remember from the question, the volume given to us is 1 dm cube, so this will be 1000 cm cube, and this will be over 1000 here. So guys, let's go ahead and bring up our calculator to complete this. So here we're going to say 2 times 58.5 times 1000, and then this divided by 1000, and that would be 117. So this would be 117 grams. And guys, here the correct answer to this question is option A here. That's 117 grams. So let's go ahead and consider the next question, guys, and that's question number 2. It says potassium trioxochlorate 5 has a solubility of 1.5 moles per dm cube at 45 degrees Celsius. On cooling this solution to a temperature of 20 degrees Celsius, the solubility was found to be 0.5 moles per dm cube. What mass of potassium trioxochlorate 5 was crystallized out? So guys, just like we did in the previous question, we are still going to determine the solubility by taking the difference of the two solubilities here while cooling the mass from 45 degrees Celsius to 20 degrees Celsius. So at 45 degrees Celsius, let's say at 45 degrees Celsius, we have the solubility to be 1.5 mole per dm cube. So at 20 degrees Celsius, the solubility went down to 0.5 moles per dm cube. So with this, it means that the solubility will be 1.5 minus 0.5, and this will be 1 mole per dm cube. So guys, now that we've gotten this, our next concern will be, since we've gotten or we've established that for each dm cube of this crystal that we have 1 mole. Now, since we've established this, we want to know the mass of 1 mole of this substance as well, and that will be the molar mass. So we are going to use, already the molar mass has been given to us in this equation. So 122.5 grams of this is for 1 mole of this substance. So in order to get the mass of this substance, that's potassium trioxochlorate 5, that was crystallized out, we also need to check out the number of moles we have from the solubility, and guys, that's 1 mole. So we are going to say what mass of these will be required for this 1 mole. So absolutely it's still going to be the same. When we cross this, we're going to have, so let's call this the mass. So you're going to have the mass to be 122.5 times 1 mole, and this over 1 mole. So this is going to be 122.5 grams. And that's it for this question, guys. So let's go ahead and wipe this off, and then let's consider the next question. That's question number 3. So guys, here in the question number 3, we also have a graph here. The question says, in the graph above, at what temperature is the solubility of KHCO3 and NaCl the same? So guys, so KHCO3 is potassium hydrogen trioxocarbonate 4, and we asked at what temperature is the solubility of potassium hydrogen trioxocarbonate 4 and sodium chloride the same. So we have options A to D here. A is 37 degree, B is 18 degree, C is 35 degree, and D is 42 degree. So guys, the only thing we have to do here is to just take note of the graph showing potassium hydrogen trioxocarbonate 4, and then that's showing sodium chloride, and then check where they intersect, and then check the corresponding value under the temperature, since the question says at what temperature. So guys, it's at point 37 that this curve actually blends with this other curve. So that's the answer to this question. This point where they intersect, tracing it down to this line of the temperature, that's 37. So that will be the answer to this question, option A. So let's consider the next question. Question number 4, it says, the solubility in moles per dm cube of 20 grams of CuSO4 dissolved in 100 grams of water at 180 degree is. So guys, we're also given the molecular mass of the elements here. So we are going to actually solve this. You are given the atomic masses of the elements here. So we are going to solve for this. So guys, let's just quickly zoom into our workspace here. So the first thing to remember is that the number of moles of a substance is the reactive mass over the molar mass. So number of moles is always the reactive mass over the molar mass. So we're going to write it down here. So number of moles of CuSO4, that's copper 2 tetraoxosulfate 6. So this will be reactant mass, let's indicate this as Rm, over the molecular mass, let's indicate it as mm. So guys, the reactant mass is the mass given to us in the question, and then the molecular mass is the one we have to calculate from the atomic masses given to us. So using the atomic masses given to us, let's calculate the molecular mass. So molecular mass is going to be, copper is 64, then plus sulfur is 32, then plus oxygen is 16, but times 4 here since it has 4 here. So guys, let's add this up together. Actually, let's start with 16 times 4, which is 64. Then let's add this to 32. Then let's add this to the last 64. And that's 160. So the reactant mass, guys, is given to us from the question, and that's 20 grams. So in order to find the number of moles of CuSO4, we are going to do the reactant mass, which is 20 grams over the molar mass, which is 460 grams. So let's go ahead and solve these together. And this will give us 0.125 moles. Alright, so guys, now we've gotten the number of moles. Let's go ahead. The question actually says the solubility. So guys, the solubility will be the number of moles times 1000 over the 100 grams. That's the solubility of 100 grams of this. And that will be 1.25 moles per dm cubed. So that's it for that question, and option A is the answer to this question. So let's go ahead and wipe this, and then let's consider the next question. Question number 5, it says, what process is illustrated below? So we have a reaction here forming from a solid to an aqueous solution in the presence of water. So guys, option A here says melting of a solid, B, sublimation of a solid, C, decomposition of a solid, D, formation of saturated solution. So guys, the answer to this question is formation of a saturated solution. The process illustrated is the formation of a saturated solution, because a saturated solution is a solution in which the maximum amount of solid has been dissolved in a solvent at a given temperature. So guys, you've seen this equation. The solid has actually been dissolved to give an aqueous solution. So that's the formation of a saturated solution. Let's look at the next question, question number 6. So we have a graph here, and we are to use the graph to answer the question. So the question here says, at what temperature are the solubility of L and K the same? We have options A, 75 degrees Celsius, B, 90 degrees Celsius, C, 100 degrees Celsius, and D, 82 degrees Celsius. So guys, the answer to this question is option D, that's 82 degrees Celsius. So let's consider the next question, question number 7. It says, a supersaturated solution is said to contain A, more solutes than it can dissolve at the temperature. At that temperature, B, as much solute as it can dissolve at that temperature, C, as much solute as it can dissolve at that temperature in the presence of undissolved solutes, D, more solute than it can dissolve at that temperature in the presence of undissolved solutes. So guys, option A is the correct answer to this question. A supersaturated solution is said to contain more solute than it can dissolve at that temperature. So let's consider the next question, question number 8 here. It says the solubility of a salt of molar mass 101 grams of 20 degrees Celsius is 0.3 0.34 moles per dm cube. If 3.40 grams of the salt is dissolved completely in 250 cm cube of water in a beaker, the resulting solution is A. Supersaturated, B. Saturated, C. Unsaturated, D. A suspension. So guys, let's go ahead and observe this together. So let's zoom into our workspace and see this together. So the number of moles of this substance is going to be the mass over the molar mass. So here we're going to have 3.40, which is the mass here reacting, and the mass of the salt that is dissolved completely, and then the molar mass here is actually 101 as given in the question. So let's go ahead and calculate for this. 3.40 divided by 101, and guys, this is 0.034. So let's take this as the number of moles, and then the solubility here is going to be the number of moles over the volume here. So we are going to have, since we've gotten the number of moles, 0.034 over 0.25. So let's calculate this. This will yield 0.136 mole per dm cube. So guys, with this, since the resulting solution has a solubility that is less than the 0.34 moles per dm cube, which is the solubility of the salt here in the question. Now, since this solution you have a solubility that is less than that, it means it is unsaturated. So guys, the answer to this question will be option C here, and that's unsaturated. So go ahead and wipe this off, and then we'll consider the next question. That's question number 9 here. It says, which of the following mixture is an example of a colloid? We have A. Sugar dissolved in water, B. Milk, C. Orange juice, D. Salt water. So guys, the answer to this question is option B, and that's milk. So let's consider the next and the last question here. Question number 10 says, the solubilities of different solutes in a given solvent can be compared by A. Plotting their solubility curves on the x-axis only, B. Plotting their solubility curves on the same axis, C. Plotting their solubility curves on separate axes, D. Plotting some of the solubility curves on the x-axis and others on the y-axis. So guys, the answer to this question will be option B here, plotting their solubility curves on the same axis. And that's all for this video, guys. This is where we'll end this video, guys, for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. If you have any specific question regarding this video, guys, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, we also want to encourage you to join our YouTube channel community by hitting the join button below. Then you gain access to this community where we'll post a lot of updates for you guys on JAMB examination. This will help you even as you prepare for your JAMB examination for the year. So thank you once again for watching this video, and see you on the next one.